In this video, we will show you the principle of action of Lyapko applicators and their interaction with the human body. The applicators consist of 5 types of needles arranged in the necessary sequence on a rubber base. 3 out of the 5 types of needles undergo galvanization. This procedure is needed to grow a layer of another metal on the needle everywhere except for the tip. The needles, placed in the correct sequence, begin to emit galvanic currents upon contact with human skin. The applicators include needles made from the following metals: ordinary iron, nickel-plated iron, galvanized iron, ordinary copper, and silver-plated copper. Each type of needle is represented by 12.5% to 25% of the needles on the applicator. After the galvanization of the needles in a non-invasive, safe form, the assembly of the applicator follows. The base of the applicators is made of medical-grade silicone or rubber. Each applicator has its unique color and barcode. The needles in the Lyapko applicator are arranged to form a galvanic cell. Each galvanic cell consists of 3 components: anode, cathode, and electrolyte. As an example, the galvanized needle acts as the anode, the copper needle as the cathode, and the electrolyte can be human sweat and intercellular fluid. When the circuit is closed through a conductor and load, electrons begin to move, doing work. The filament in the light bulb starts to glow and heat up. Zinc transfers an electron to copper, and copper transfers it to hydrogen. Hydrogen is reduced, while zinc is oxidized and dissolves, saturating the solution with zinc ions. When the electrodes are closed, all the energy of the electromotive force is converted into heat. The solution and anodes will heat up. When the Lyapko applicator contacts human skin, a heating effect is felt. This is often accompanied by a slight tingling sensation because intercellular fluid is a complex colloidal solution that conducts electric current. It contains various salts, organic and inorganic acids, such as ascorbic, succinic, lactic, and acetic acids. In our case, the needle acts as a short-circuited element. Cations accumulate at the cathode, while anions and acid residues accumulate at the anode. The anode transfers electrons to the cathode to the cations, which leach hydrogen, and the released ion enters the body. By inserting 2 needles with different metal coatings into the skin, we create a battery where human sweat and intercellular fluid serve as the electrolyte. The potential difference in such a battery can be calculated using an electronegativity table or measured. The skin represents a multi-layered, diverse electrolyte of varying conductivity. The surface of the skin acts as a conductor made of concentrated electrolyte in the form of sweat. Let's measure the potential difference of such a cell. Zinc has a potential of -0.76. Silver has a potential of +0.8. The potential difference is 1.56 volts. Before you is a diagram of the distribution of galvanic currents in human skin. Here you see a diagram of the potential difference between various coatings or the surfaces of uncovered needles. Here is the potential difference between the coatings and the base metals of adjacent needles. Here is the potential difference between the coatings of adjacent needles. The use of Lyapko applicators provides the following effects. First, normalization of regeneration processes, improvement of vascular permeability, elimination of edema. Second, effective fat burning due to significant acceleration of metabolism. Third, immunotropic, immunomodulating, and immunostimulating effects. Fourth, local and overall increase in body temperature. Fifth, normalization of the acid-base balance in the body. Sixth, deoxidation of free radicals by free oxygen and their transformation from carbon monoxide into harmless products, carbon dioxide and water, which freely exit the body.